Alright, this is number 31. This is a merry-go-round, and the technician needs to figure out the torque needed for the new motor to make this merry-go-round work. The merry-go-round has to start with an initial rotational velocity, omega, of 0, and it needs to get to 1.5 radians per second in 8 seconds. The radius is 5 meters, and the mass of this thing is 2,500 kilograms. As you see over here, the sum of the torques is I alpha. That's just the equation for torque, so I just kind of threw it up there. So here it is, torque is I alpha. One of the first things I did is I figured out that the moment of inertia for this thing, it's a solid disk, so it's 1/2 mr squared. That's on page 291. So I get the 1/2 mr squared, and I get this as its moment of inertia. It's in kilogram meters squared. And then if you look over here, we have the equation. It was omega final equals omega initial, I believe, alpha d delta t, something to that extent. I manipulated it for alpha. It's also in the book. It's in your formula sheet. Make sure you find it, manipulate it. And then I have my 1.5, my 0, my 8 seconds, and I get my alpha, which is my angular radial acceleration, I guess we can call it, and it's in radians per second squared. Here's how the units work out. Here's how you get radians per second squared. Finally, very simple last step. Tau equals I alpha. So I take my I, my alpha, and multiply them together. I get this number. It's in Newton times meters. I showed you how to get that from this already. And we'll get it in, we'll simplify it a little bit, and I get 5.86 times 10 to the 4th newtons times meters. And that's number 31.